Let's take a look at the next type of two-sample hypothesis test, and this one is called the two-sample t-test for mu. Now remember, it's a t-test when we do not know sigma, all right? When we don't know sigma, we use a t-test. And the only difference in the formula is I have S1, that's sample standard deviation 1, and sample standard deviation 2 in that spot. So let's read the problem and then we'll work this out and get a nice, easy answer. So we're talking about gambling on this one. The mean age of a random sample of 25 people who are playing the slot machines is 48.7 years with a standard deviation of 6.8 years. So we made slot machines population 1. So I put x bar 1 is 48.7, n1 is 25 for my sample size, s1, my sample standard deviation, is 6.8. The mean age of a random sample of 35 people who are playing roulette is 55.3 with a standard deviation of 3.2 years. So I made roulette population 2, and I usually do it in the order that they're written. So if you kind of did the same thing, it's going to work out that way. Otherwise, just the whole problem is flipped, but the final answer is still the same, okay? You may not realize that, but that's how it works. So x bar 2 is 55.3, n2, our sample size, is 35, and S2, our sample standard deviation, is 3.2. It says, can it be concluded at alpha equals 0.05 that the mean age of those playing slot machines is less than those playing roulette? All right, the question is, are they less? The question is always the alternate hypothesis. I'm going to jump down here to alternate hypothesis. Is it less? So I'm going to write it as mu1 is less than mu2. Less than on our sketch means left side, which means our critical value, when we get to it, will have to be negative because it's on the left side. All right, put your alpha on the left side because it's a less than value. All right, slots are less than roulette. So the opposite is that they're equal. Slots are equal to roulette. We're trying to disprove that and say it's less. So mu1 is the mean age of slot players. Mu2 is the mean age of roulette players. Our assumptions are, from what we learned before, x bar 1 and x bar 2 are from a simple random sample. We didn't have a size large enough, but one thing you're allowed to use when it comes to size or shape, because remember when you hit 30, it looks approximately normal. We talked about that. We can just say a blanket assumption, both distributions are approximately normal. Just go with that, okay? Trust me. And then last one is that sigma 1 and sigma 2 are unknown. That's why we're doing a t-test. T-test, sigma's unknown. Now to find a critical value, this is based on a degree of freedom. Remember that with a t-test, we need a degree of freedom. But I have two sample sizes. So our book recommends that we take the smaller of the two samples, which is 25, and subtract 1. So our degree of freedom is 25 minus 1 is 24. So we want to go to our chart, right? Go to our table of values, and I want to look up one-tailed, and our alpha was, I've got to cheat and look, 0.05. One-tailed 0.05, degree of freedom 24. Okay, one-tailed 0.05, degree of freedom of 24. And what value do you get? 1.711. But it's on the left side, so we have to put a little negative side in front of it. Okay, it's negative 1.711, which makes this sketch. All right, so I'm left-sided here. I have my alpha, which is the very left 5%. We can reject within there. And I have that divider, that critical value of negative 1.711. Let's go ahead and I'm going to get rid of the assumptions maybe. We will erase this part, okay? And let's do our work up here. All right, so plugging numbers into the formula. Whoops. I have a Z there. Let's put a T in that spot. All right, so what's our t-test statistic? T is x bar 1, 48.7, 48.7 minus x bar 2, which is 55.3. Already I can tell the answer is going to be negative when we're done. Minus the difference of mu1 minus mu2. Where is that? Look down here. If I brought mu2 to the other side and made it mu1 minus mu2, I'm left with 0. So this is also known as, AKA, mu1 minus mu2 equals 0. I could rewrite it that way, use a little algebra. So all that equals 0. Divided by, here we go, plug our numbers in. S1 is 6.8. We're going to square that and put it over 25. Plus 3.2, that's S2. I'm going to square that. I'm going to put that over 35. I would do the squaring first, then I would divide by 25, and I would add the two together, then take a square root, right? Get a single number. You can see that in my work. On the top, I would just subtract the 2. When I'm done, just take a single top number over a single bottom number, and we get negative 4.511. That is way out there. Because we have learned this year that in a normal distribution, most numbers go from negative 3 to positive 3. Anything beyond that is way out there. And it is. It's way out here. We can't even, it's going to go off my chart actually. All right, so negative 4.511. Hey, look where it ended up. It didn't end up in the safe area, it ended up in the rejection area, okay? So we're going to reject. So what does reject means? It means the null hypothesis is where we are saying, based on the sample, it's not true. So reject HO, the null hypothesis, there is significant evidence to suggest what are we suggesting here? We're suggesting that slot players to suggest, yes, the mean age of slot players is what? It's less than. That's what we're proving here. So it's less than roulette players. The mean age of slot players is less than roulette players. Okay, one thing to remember when you do hypothesis testing, when it's two samples, we have to have the same type of data. So it's age and age. I can't have age and weight. It's not possible, okay? I can have height and height. I can't have height and weight. It's not possible, okay? So the previous problem, we had dexterity test score. Dexterity, okay? I didn't put 100 meter time and high jump height. It doesn't make sense. They have to be the same value being compared, okay? So that's our two sample t-test for mu. Our last type of test will be the pair t-test, and that's our last topic for the semester. And then we'll do some review problems too. Alrighty, you have a great week.